No. I would like to thank Demetrius Venetstralis and the University of Kingston for hosting this competition today. Thank you so much to you. And a very warm welcome on behalf of the Institution of Mechanical Engineers to this second Engineering Design Challenge that we've held in the Greater London region. However, we have held 8 Engineering Design Challenges in the Northwest region, and they have been extremely successful. So I'm sure this is going to be the same. There is going to be another Engineering Design Challenge in the Northeast at Durham University in April, and hopefully another one in Southampton later in the year. So now, it gives me great pleasure to introduce your head of school, who is Professor Nesip Sahan-Akyai.
Yes, well, thank you very much. Yeah. Yes, I am the head of hosting school, and I welcome you all to Kingston. We arranged this competition today, and thanks to Demetrius, who was the chair of the local organization committee. He did a good job with academics and students, and also Susan to arrange the media coverage of the event. So if it goes well, I take the credit. If it doesn't, Demetrius. We value this competition because through our engineering education, we encourage design and build activities and hands-on engineering approach. And this competition fits perfectly well with our vision. And also it has got an additional edge. It's a competition, so it pushes the student a bit more. They put effort in it, they enjoy it, and we have participation is quite good. So, welcome to Kingston. I hope you will enjoy the day. If you do, please tell me. If you don't, tell Demetrius. And I will introduce you to our Dean of Faculty, Lucy Jones, who will give us a few words of welcome.
Thank you, Nesip. Hello, it's really lovely to have been invited here today to watch this competition and to see the KU team take part alongside the other universities that are here today. It's really great to have you all here, and I hope that you have a fabulous time. I was watching some folks playing table tennis outside in the sunshine, and I hope you'll appreciate the effort we put into sorting out the weather for you as well, and that you have a really great time here today. It is really important to see these types of events taking part within universities, to actually see teams working together on challenges, sometimes doing amazingly well, sometimes failing, but learning a huge amount from those challenges along the way. And clearly as an engineer, that's part of the game for you. I am also an engineer, but my material of choice is DNA, as I'm a genetic engineer, but many of the principles still apply. So I hope that you have a great time, that the team spirit is really strong, that you cheer on those successes and you cheer on those failures as well. And if KU win, so much the better, but if not, we will be magnanimous in defeat. So have a fabulous day. Take care.
Right, the outline of today. Today is a competition. The main part of the day is a competition between devices climbing up the outside of a piece of 15mm diameter copper tube and returning to the starting position carrying a chain. The winner will be the device that repeatedly completes the cycle in the shortest time. So it should be a very exciting competition. There are 4 sections to the competition today. And they are, as they will take place today, the presentation competition, where one team from each university will demonstrate their verbal and presentational skills. The second part of the competition is the poster competition, where one team from each university will demonstrate their graphical and pictorial skills. The third part of the competition is the peer review, a very important aspect, where each team will review the devices from the other teams and rate them so that we identify the best design from your point of view. And then the main challenge competition this afternoon, where the teams will demonstrate their ability to produce a design solution and compete with the best. Because obviously the teams here today are the best in the Greater London region. So now, it gives me great pleasure to introduce our keynote speaker. The keynote speaker should have been Dr. Colin Brown, the Engineering Director of the Institution of Mechanical Engineers, but unfortunately he couldn't be here today. However, I'm delighted and very pleased to announce that Dr. Helen Mees, the Head of Engineering and Society for the institution, has kindly agreed to take his place. Dr. Mees will relate a popular subject to a design challenge to demonstrate that the principle of this design challenge can be related to any type of problem. So, Dr. Mees, thank you.
Thank you, David. Yes, as David says, my esteemed colleague Colin Brown, unfortunately, is not able to come today. So I'm afraid you've got me. It's not so bad, but we'll see how we go on. Now, I'm hoping that I could have my presentation up, if that's all right. Let's see if we can get this started. Oh. Why is it doing that? Because I'm not pressing the right bit. There we go. I put some hashtags up there. I like people to tweet and Twitter, so please feel free to do that. So my name is Dr. Helen Mees. I am an engineer myself. I'm an electromechanical power engineer. I've spent a considerable number of years in industry as well as in academia, and it's been a while since I've stood looking up at students in a lecture theatre, so I'm slightly uncomfortable right now. So this morning, really, I'm going to break my presentation into two sections. The first, actually, is to talk about you as engineers and the engineers that are in this room. This is just really, you've probably seen a lot of articles recently in the news. You know, engineers, let me make no bones about it, engineering, we are very short of engineers in the UK and internationally. We need approximately somewhere in the region of 100,000 engineers coming into the industry every year for the next 5 years if we're going to maintain the level of manufacturing and technology in the UK. That's a huge number of people, and quite frankly, I'm not quite sure where they're all going to come from. It's going to be a great challenge for us both as the UK and internationally. And you may have heard Ed Miliband recently talking about the lack of female engineers. I have spotted one or two coming in. I'm hoping I can see one up there, and maybe a few more yet. We only have 6% of registered chartered or registered females who are engineers in the UK, and that's pretty consistent across the globe. I know I was talking to some Germans recently, and they have the same problem. It's around about 8%. So we are not only short of engineers, we're also short of female engineers as well. And to be honest, this actually puts you all in a really great position, actually, in some respects, because there's an opportunity for you to be involved in technology and the development of that technology globally. The doors are now open to you, probably even more so than David and myself and you know, some of your lecturers. The opportunities for you now are even bigger. And the reason for that really is the skills that you learn in university, taking part in this sort of challenge, and the knowledge that you accrue as part of your degree makes you very highly prized, both in engineering, you know, actually in the nuts and bolts side, but also in the business side of engineering as well, and in the innovation side. And one of those skills that I know that you all have, otherwise you wouldn't be here today, is problem solving. And it's that ability to problem solve which is really key to your skills as an engineer. And so that's something that I want to go on to talk about. You may or may not have come across this, I'm not sure. This is CDIO. It's an international way of thinking about problem solving. It's conceive, design, implement and operate. And the logic to that is really what you've been doing in this design challenge. And it's all about really sort of solving problems. And in fact, this slide itself actually came from Singapore and a Bangkok University. So you can see it's an international understood process. So if we think about how we apply this, now obviously you know you're here today for your design challenge, but I've got a little bit of a design problem myself here, and you know, I think you might find this interesting. Here's a question for you. Is there life on Mars? Oh dear, that all went quiet, didn't it? All right, okay. Bit of a straw poll, hands in the air. Who thinks that there might be, or could have been, I'll give you a could have been, life on Mars? Okay, that's okay, right? Yeah, maybe a bit more than half, perhaps. Okay, that's good. Now, I think there's an opportunity today to test that theory. Okay, so what I'm putting forward is my idea, my thought on this subject. So let's conceive. There's members of the front row that will get this. There's people at the back who won't. So let's conceive initially our idea that there is life on Mars, or that there has been. Could we perhaps think about that life on Mars, people might be walking around on Earth now who are Martians? I think a few people thought David Bowie was back in the day. This is from 1971. I am not quite old enough to remember this, but I won't dwell on that. You know, are there people walking around that could be Martians? Well, I guess, you know, if we kind of look around, we might, once we've conceived our idea, we might want to design a solution to that. And one way of doing that is to obviously look around and see if we can see people who might be aliens. Now, obviously, we'd be looking for little green men, not, you know, characters from Toy Story, but that's not the point. You get the idea, okay? There's the design problem. So we've got to implement a process to test out our design, haven't we? Well, perhaps we might see them on television. We might see aliens on television. Although I think Patrick Troughton kind of got to it probably in 1967 as Doctor Who and killed off apparently these are ice warriors from Mars. In fact, I think the conclusion that could be drawn from that is actually they're not really real, because it was a man in a suit. This is Bernard Bresslaw, for those people who do remember this gentleman, who actually played one of those characters on television. So, you know, perhaps we need to look elsewhere. Perhaps instead of on television, perhaps we maybe saw them in books. And you may or may not have read this book. This is The War of the Worlds. This is actually, the book itself was written in the 1800s, but this is a reprint from the 1960s. And, you know, it tells us something about Martians, what we would expect, what they might look like. So it gives some credence to it. And in fact, actually, one of these aliens has been sighted in Woking, of all places. But it turns out it's just a statue. So it's okay, we're all safe. And indeed, you know, we might, it's probably come from this, which is an album cover. Again, you're probably too young to remember this, but I do recommend it if you've not listened to this album. So the problem we've got there is that, you know, we've had a look at TV, we've had a look at books, we've tried to see whether these aliens exist. The opportunity to see if our theories are correct is to operate our idea. And in this case, actually, War of the Worlds did come to life in the 1930s, just prior to the outbreak of war. The book was turned into a radio programme, and it was broadcast live from a studio. And instead of it being set in England, it was set in America. And within 40 minutes of the broadcast announcing to the world that aliens had landed in New Jersey, 1.2 million people went into complete and utter meltdown and panic, and the army and the police were out on the streets trying to stop people, going crazy because, and apparently there were some suicides. I didn't know. It's really sad. So that this whole thing ended up in being quite a sad scenario. So perhaps this approach to looking for aliens is probably not the best way to go about it. There are probably no aliens walking around on the planet. So maybe we have to rethink our process. So maybe we can put a little bit more scientific spin on it. Perhaps we can look at it from the point of view of, what would be the conditions for life on Mars to exist? And maybe we need to focus on that. So we can conceive that life and growth needs to have some sort of universal conditions to exist. So we might turn to our design process and we might look at what those conditions might be. You can read that, okay. So we might look, for example, for metals. We know that we need metals, a small amount of metals to be around for us to exist. I'm going to look at the lady over there. Well, actually, I'm going to look over here because she's looking at me very funny. She knows all about how you make things that live, and so I'm not. I'm a mechanical engineer. I do apologise now. So for things to do this, we need metals. We also need to understand whether it's a life form like ourselves, Maybe it's an ammonia-based life form. So it'd need completely different conditions, Ammonia has a lower freezing point, so maybe these creatures could live in very cold temperatures, for example. And also the atmosphere. The atmosphere on Mars, we know now, is nothing like it is on Earth. And also the pressure. Actually, the pressure is about 6 millibars. Now, for humans to exist, it needs to be a lot higher than that. And in fact, if you get down to about 60 millibars, the water in our bodies would start to boil off. So this is not a good condition to be in. And perhaps, life has developed so that you could live at those very, very low pressures. And also radiation. How are we going to overcome the problem of radiation? It's 100 times stronger, the sun's radiation on Mars than it is on Earth. That's going to be pretty much a killer for us anyway. So let's not be put off by this. Let's see what we could do to implement our process. And by that, we need to go and look at Mars. We need to go and see what's going on there. Now, apparently, according to Wikipedia, there are 51 space missions to Mars. 51. I was quite surprised at that. And the first one was sent up in 1960 from the Soviet Union. It had a very catchy name of 1M1. And the reason it's only on a postage stamp is because it blew up just as it got out of Earth's orbit. So it didn't get anywhere near Mars, which was a bit of a shame. But then we kind of tried again, and we sent Mariner 4, and we launched that in 1964. And it got within about 6,000 miles, actually, of Mars, and before it kind of drifted off into space. But what it did tell us was that there was no magnetic field around Mars, and that the surface temperature of Mars was minus 100 degrees. So we got some data. That was useful. We didn't land on Mars for another 11 years. And in 1975, I was 2. We got there and we were able to take the first compounds. We were able to actually have a look at what the soil was telling us, and we found some. We were looking for organic compounds, and we did do some experiments, and they weren't quite accurate. We got some negative results, and then there was a few blips, and so we weren't quite collecting the sort of data that we really wanted, until we sent Mars Pathfinder. And I think most of you would probably be familiar with this. This is Sojourner. This was arrived on Mars in 1997. And it was intended to last for only a few days, and actually it was there for several months. And it measured pressure, temperature, it measured wind speed. It confirmed that there was no molten core to the planet, and hence no magnetic field. And then, of course, we had Curiosity. That launched in 2011, and it landed in August 2012, actually on the opposite side to where Sojourner was. And Curiosity actually measured methane. It was able to detect methane in the rocks. And it measured up to 10 parts per billion for 100 days, which was quite extraordinary because we weren't expecting to see anything. So could this be the signs of life on Mars? Could this be, the remains of those creatures? Now, there are lots of ways that we could generate methane, and I'm not going to spend a huge amount of time going into those, but Curiosity did detect various chemical compounds that would have formed in fresh water. It also found rocks that looked, like worn, weather-beaten rocks that maybe water had been flowing over for many centuries. But the radiation really was way too dangerous. And the thought that perhaps we could send people to go and investigate this is probably a bit crazy at this point. Now, I'm sure you're all aware that actually recently an organisation was set up to send people to Mars. Of 100 people were selected to go on a one-way trip to set up a colony on Mars. Obviously, they're going to have to take all of their equipment with them. They're going to have to be able to deal with all of these, the pressure and the wind and the radiation particularly. I can only envisage that they would end up living underground, and perhaps they probably wouldn't live for very long. So perhaps we need to look for a better way. So we start our design process again. This is the last bit, don't worry, it's not going on forever. So what about if we look for fossils? We have fossils on Earth, right? So that tells us a bit about the history of the planet, and it tells us how animals evolved and how the world has changed over millennia. So maybe we could look for fossils. Well, we thought we'd found one. What does that look like to you? A bone, yeah, absolutely. It really flummoxed a lot of people when that picture came back from Curiosity. And some people were quite scared, actually, but we couldn't tell whether it was a bone. We didn't have the technology on Curiosity to give us that information at that point. So, okay, we've got an idea there could be fossils. Let's use the design process to see and figure out whether or not we can work out whether they are fossils. Now, one of the things we do have here on Earth are meteorites. We actually have 132 meteorites on Earth that have come from nearby planets. We know that because the radiation levels, the time that they would have been in space, gives us an idea. It's a bit like cutting a tree and looking at counting the rings. It's that kind of thing. We can tell a lot about the life of that rock by looking at its features. And we also had the data from Viking 1, so we could compare those that data. And this rock is apparently called ALH 84001. It weighs about 2 kilograms, and it was picked up in Antarctica in the 1980s. And the radiation from it tells us that it's probably a rock from Mars. Because it contains carbonates that are very similar to those found here. And so it gives us an idea of whether or not there might have been water on the planet about 400 million years ago, which would be about right for a comparison with Earth. And a scientist called David MECHE from NASA wanted to have a look a bit more deeply into these rocks. He wanted to do some more research, and what he found was this, and you may have seen these pictures, and you can see these little wiggly worm kind of looking things. And he hypothesized that they might actually be the fossil remains of bacteria. Now, if that was true, my goodness, what a breakthrough that would be, because we have similar things on Earth. We've got something that we can compare against to test out our theory. And this photo was actually taken from the University of Queensland to show that actually, you know, there are existing things on the planet that look about the same size, they're about the same shape. And, you know, maybe we've got something here, maybe there's something. Well, just like the bone, you know, the fact that it looks like something doesn't necessarily make it something. And, you know, if it's a duck, if it looks like a duck, it doesn't necessarily mean that it's going to walk like a duck or, you know, sound like a duck. So there's no real proof that it's a duck, okay, if you get my meaning. So we kind of have to turn to the scientists to sort of test out our theories and knowledge for us. And Professor Charles Cockle from, he's a professor of astrobiology from University of Edinburgh. He is a real expert on Mars. He has studied Mars for years. He's also the first president of the Mars Club. And in 1992, he actually stood for general election for the Forward to Mars party. Slightly off his rocker. He did actually get 91 votes, so you know, he did quite well. But he is a real expert in the subject, and he's been looking at the idea of actually whether there has been water at some point on Mars. And he said, and I'll leave you to read that first part, but he said that that life was possible does not make it inevitable, though. Of course, it could have been uninhabited. So there could have been water on Mars. There could have been the opportunity for life. It just might not have manifested itself the same way as it has here. So really, you know, what he thinks is that there's a possibility, but maybe not. But the question is, what do you think? Okay, so I've put forward some hypotheses. I've put forward some ideas that, you know, maybe there's some fossil records, maybe we can look for life using, you know, scientific principles. Maybe we've got Martians walking among us. Does that change your view of whether there's life on Mars? Quick straw poll again. No hands! Okay, that's interesting. So, you know, the idea that there might be Martians is our initial thought. Through the design process and through applying our understanding of problem solving, we can come to some conclusion. Whether that's right or wrong, we can debate the issue. And maybe that's something we can have a chat over lunch. I'd be interested to hear your views. But for now, we need to go back to the real reason why we're here. So whether it's looking at aliens or whether it's designing a machine to climb a pipe, the idea of conceiving and designing and implementing and operating applies to just about anything. So it only really remains for me to say thank you very much for listening. I do wish you all good luck. I am going to be part of the judging team, so I'm very excited to see what you come out with today. And really think about this process when you're carrying out your challenge today. Think about what it is you've gone through to get to this point and to become one of the best in the competition. And I hope that sets you up for the day and really gives you the enthusiasm to carry this forward. So thank you very much for having me.
Thank you, Helen. That was extremely good. And I'm privileged to have witnessed this presentation, this keynote speech from Colin and Helen. And I think you did equally as well as Colin.
Thank you.
Thank you.